Hello students, good morning everyone. Now, today we are going to discuss electrochemistry. And before going to start the electrochemistry, as we know that yesterday itself, the central government have announced the new date of Neet examination, Neet 2020, that is July 26th. So almost around 2 months, 15 days, 20 days around still. Okay. So there was a one advantage and one disadvantage because of this long prolongation. Coming to the repeaters, for repeater students, so they are going to get tough competition from the regular students. So be careful. So without wasting the time, focus on your studies. Coming to the regular students, it is an advantage for them. Why? Because after their board examination, around 4 months time they got, around half of the long term coaching. Okay, I think this is the only year after they finish the examination, they are getting this much of time for the preparation. So it's a beautiful opportunity for you people. So take this an advantage and good luck. Okay, let us start the electrochemistry. As we know, actually those who are really from biology background, because of the solutions, mathematics solvation, people usually feel difficulty about this electrochemistry, but if you completely watch my video, definitely after the finishing this video, you feel very comfortable in solvation of these electrochemistry problems. Okay, let us start. In electrochemistry, mainly, electrochemistry is nothing but the branch of chemistry which deals about mainly electrochemical cell, electrolytic cell, and batteries mainly. Okay, so in that various of topics are there. Mainly we discuss electrochemical cells, electrolytic cell, and batteries, corrosion, everything we will discuss in this topic. Okay, in this electrochemistry, if we start, as we know, conductors and resistors. What is the difference between the conductors and resistors? Conductors are nothing but these are the substances which allows to conduct the electricity through it. For example, you take metals, iron rod you take. So through the iron rod it allows the conductivity of electricity through them, current electricity through them. And those substances we call it as what? Conductors. So conductors are nothing but simple in shortcut how you can write. This is what? That allows current electricity to pass through it. Okay, and that substance we call it as what? Conductors. And these conductors we are dividing into two types. The conductors we are dividing into two types. What are those? The first one is electronic conductors. The second one is electrolytic conductors. Electronic conductor, the name itself. Electronic conductors are nothing but here the conductivity is because of transfer of electrons. Okay, so here the conductivity is due to transfer of electrons. Then those conductors we call it as what? Electronic conductors. Here electrons are transferring from where to where? From anode to cathode. So from negative electrode we call it as what? Anode. From anode to cathode. Okay, from anode to cathode the electrons are moving. Okay, next whereas coming to the electrode, simultaneously we will discuss both. Okay, coming to the electrolytic conductors, here the conductivity is due to migration of ions. Here the conductivity is because of ions. Then those conductors we call it as what? Electrolytic conductors. Here the ions are moving from where to where? Generally cations are attracted by cathode, anions are attracted by anode. Okay, so the ions are attracted towards opposite charge electrode. Okay, so that is what. Next one, in this electronic conductors, is there any transfer of mass? No way. Why? Because here electrons are only moving. Okay, so here there was no transfer of matter. Only electrons are migrating. Whereas in case of electrolytic conductors, there was a definite way, because all cations are migrated towards cathode, anions are attracted towards anode. Because of this, what happened? Mass may transfer. So there was a transfer of matter. And one more important and beautiful point is this electronic conductors. So if the temperature was increased, if you increase the temperature of these electronic conductors, then their conductance decreases. That point you should remember. If you increase the temperature, what happens? The conductancy of these electronic conductors decreases. Whereas in electrolytic conductors, it's reverse. That is, if the temperature was increased, then their conductancy also increases. Okay. And is there any mass deposition in electronic conductors? No way. Okay, there was no deposition of matter or mass. Whereas in case of electrolytic conductors, there was a deposition or a decomposition of the substances or accumulation of the substances at electrodes. Okay, so deposition at electrodes takes place. Okay, examples for this: all metals are examples for electronic conductors, all alloys also examples for electronic conductors, and cadmium sulfide and cadmium and copper sulfide. Here you may get the doubt. The sulfides of cadmium and copper are electronic conductors because of defects present in it. Defects, okay, no defects, because of either stoichiometric defects or non-stoichiometric defects, metal excess or non-metal, whatever it may be, because of the presence of the defects. Okay, here the conductivity is, that is why they both are examples for electronic. What about the electrolytic? All acids, so bases, so salt solutions are examples for electrolytes. Okay, so that is acidic solutions, bases and salt solutions, all are examples for electrolytic. I think there was a clear differentiation between electronic and electrolytic. Clear? Next, move to the next topic, that is what? Electrochemical cell. Electrochemical cell and electrolytic cell. What is the difference between these two? See, electrochemical cell and electrolytic cell. If you know the difference, then we after that you know what is exactly electrochemical cell and electrolytic cell. Okay, first let us differentiate them. Electrochemical cell is nothing but the cell which converts chemical energy into electrical energy. Remember that. Okay. For example, cell batteries. We are using the mobile phones. In the mobile phones, we are using a battery, right? Okay, and that is their chemical energy is converting into what? Electrical energy. So the cell which converts chemical energy into electrical energy, then that cell we call it as what? Electrochemical cell, ECC. Whereas electrolytic cell means reverse. That means it converts electrical energy into chemical energy. Electrical energy into chemical energy. Then that is what we call as electrolytic cell. And one more difference. This is one difference. And one more difference is between the electrochemical cell and the electrolytic cell. Most important, that is the polarization. Means electrodes. In case of electrochemical cell, anode is negative. Remember that. Anode is negative. Cathode is positive. Anode is negative. Cathode is positive. Simply remember that Lone, you remember. Lone. LO means left side oxidation. Anode is negative. AM means what? Afternoon. AM stands for what? Anode is negative. Simply. No need of LO also. Just remember AM. AN. Anode is negative in case of electrochemical cell. But in the case of electrolytic cell, quite opposite. You may get that out. If the polarization is opposite, is the reaction is also opposite? No. Reaction is same. Okay. Reaction is same. Anode is oxidation, cathode is reduction. Only polarization only difference. Okay. So anode is positive. Cathode is negative. Cathode is negative. There is a major difference between the electrochemical cell and the electrolytic cell. And one more important difference. Electrochemical cells are made up with two half cells. It has two half cells. It is made up with two half cells. Okay, that is one is oxidation half cell, another one is reduction half cell. Two half cells it has. Whereas electrolytic cell, it is not having two half cells. Only it is made up with only one cell. Only one cell it has. Okay. Next, and one more thing, in these two half cells, to connect them, okay, so we are using salt bridge. Salt bridge is required. Salt bridge is required in case of electrochemical cell to neutralize this positive charges, to accommodate the charges formed in both the half cells. Definitely we should use the external salt bridge. But in case of electrolytic cells, there was no need of electrolytic cell. Salt bridge. Okay, there was no need of salt bridge, so that we are not using the salt bridge in case of electrolytic cell. Next, coming to the spontaneity, which is a spontaneous process, which is a non-spontaneous process, and which is reversible and which is irreversible. Remember that electrochemical cell means conversion of chemical energy into electrical energy is a spontaneous phenomenon. So this is a spontaneous. Okay, spontaneous, and also it is reversible. It is reversible. Whereas electrolytic cell, it is a non-spontaneous, and it is irreversible. Irreversible. Simple point. Spontaneous means what? The phenomena which is taking place on their own. For example, you take this marker. If you keep it here, without holding, if you leave it, immediately it will fade. This is a spontaneous phenomenon. If it can go up, no chance. If you want to bring this upward, then we should use some external force. Okay, so downfall of this is a spontaneous, going up is non-spontaneous. Okay, similarly, you take the battery, cell battery. If you keep the battery in the mobile phone, transfer of the chemical energy into electrical energy. No need of any external forces. Okay, so it's a spontaneous phenomenon. Conversion of chemical energy into electrical energy is a spontaneous phenomenon. But if you want to charge that, you should plug in the flux box, and okay, you should apply a high electrical voltage, then voltage present in the battery, then only the transfer of electricity from external source to battery. Okay, that is what? Non-spontaneous. It is not taking place on their own. But transfer of energy from battery to the conversion of chemical energy into electrical energy is spontaneous. That is why electrochemical cell is a spontaneous cell and it's a reversible. How it is a reversible? You may get that out. See, for example, from the electrochemical cell, if you take the galvanic cell, its maximum voltage it can produce is 1.1 volts. So, if the external voltage is less than or equal to 1.1 until it becomes at what? Electrochemical cell. Once the external voltage is greater than 1.1, then the electricity is transferring from external to cell. Means it is converting, it becomes what? Electrolytic cell. Electrical energy is converting into electrochemical cell. That is why it can be act as both electrochemical cell and electrolytic cell. When it can act as electrolytic cell, when the external voltage is greater than its internal voltage, then it becomes what? Electrolytic cell. That is why it's a reversible cell. Electrochemical cell is a spontaneous cell and reversible, whereas electrolytic cell is a non-spontaneous and it is irreversible. Okay, so these are the main differences between the two cells. Okay, now let us discuss electrochemical cell in detail. Electrochemical cell. So as already we discussed, electrochemical cell means the cell which converts the chemical energy into electrical energy. We call it as what? Electrochemical cell. So which converts chemical energy into electrical energy, which is called electrochemical cell. And it has how many half cells? It has two half cells. Okay, one is oxidation half cell and the second one is reduction half cell. And the first electrochemical cell was constructed by the scientist Galvani and Daniel. That is why we are calling this cell as galvanic cell or Daniel cell. And both are same. Galvanic cell, Daniel cell, voltaic cell, all are same. Don't be confused. Okay. So Daniel cell or voltaic cell is an example of galvanic cell. Voltaic cell is nothing but if the two half cells, one half cell is zinc sulfate, another one is a copper sulfate. If you use the two half cells, then that is called what? Voltaic cell. That's the best example of galvanic cell. Okay. Anyhow. So this is about galvanic cell or voltaic cell. If you look at the galvanic cell construction, if you take in the galvanic cell, I am taking an example: zinc sulfate, copper sulfate, copper. But cell I am going to take. Always this is IUPAC notation. We will discuss that later, how to write these all notations. In this IUPAC notation, left side is always represents what? Anode. Left side is always be anode, right side is always be cathode. So in the galvanic cell, left half cell is always anodic half cell, right side half cell is always be cathodic half cell. So I am taking the two half cells here. So this is a zinc rod and this is zinc sulfate solution. Similarly, right side half cell. This is copper rod and its aqueous solution, that is CuSO4, and this is C. And these two are so this is what? Anode. Anode means negative. This is a negative and this is positive. And next one, in order to neutralize them, we are using a salt bridge here. This is the salt bridge. So this is a construction of galvanic cell. So if you look at these reactions taking place at this, so here anodic means oxidation. Anode, always remember one point. Lone, you remember, electrochemical cell. Left side oxidation takes place. Anode is negative. Simply. Left side oxidation, anode is negative. Right side reduction, RR. Cathode is positive, RRC. RRC. Lone, RRC. Okay. So next, lone. If you take the anodic oxidation reaction, what is the reaction taking place? At anode, what happened? Zinc undergoes oxidation, Zn plus 2 plus 2 electrons. And at cathode, Cu plus 2 will gains 2 electrons and they deposit as copper. Just add both. Overall reaction is Zn Cu plus 2 gives rise to Zn plus 2 plus Cu. So zinc is undergoing oxidation, copper is undergoing reduction. This is the overall reaction taking place in electrochemical cell, galvanic cell. And in this case, salt bridge, what is the use and what is the voltage when we connect these two half cells? What is the maximum voltage they generated in the galvanic cell? In this galvanic cell, the voltage EMF value, E value is 1.1 volts. 1.1 volts. Suppose if you connect this to external source, if external EMF is less than or equal to 1.1 volts, then it acts as what? Electrochemical cell. Then it acts as electrochemical cell, and it produces the voltage, and we can extract electricity from it. Suppose if E external is greater than 1.1 volts, then it becomes what? It acts as electrolytic cell. Electrolytic cell. So that slowly what happened? The electrical energy converting into chemical energy. Okay, so this is what one point you should remember. And what is a salt bridge and advantage of this? Salt bridge, if you take, it is nothing but it's an U-shaped tube. Okay, salt bridge is what? U-shaped tube, and inside the U-shaped tube, it is filled with what is present inside of the salt bridge. It is filled with agar gel, okay, plus the salt of KCl, KNO3 or NH4NO3, etc. Any one of these are all no problem. So it's a mixture of agar gel, and this agar gel is mixed with what? KCl, KNO3 and H4NO3. You may get the why only this salt? Why don't we use other salts? They specifically prefer these salts. Why? Because the mobility of the cation and anions are same in these salts. Okay, the ionic mobility of cation and anions are same. That is why they selected these salts. They fill the salt bridge in this, and if you use a salt bridge, then what happened? Suppose if it is here Zn plus 2 ions are coming in the solution, electrolytic solution, and these formed positive ions are neutralized by negative ions present in the salt bridge. Similarly, here the positive ions are produced and these negative ions are produced, and these negative ions are having accomplished by the positive ions of this present in the salt bridge. Like this they can neutralize. Like this they maintain the neutrality. So that is the advantage of salt bridge. So this is about the electrochemical cell and their construction. And the best example for this is what? Voltaic cell is the best example. Voltaic cell is nothing but zinc to zinc sulfate, copper sulfate to copper. This reaction is called voltaic cell. And one more thing, sometimes in the electrochemical cell, instead of using two separate half cells within the same cell, by using perforated as salt bridge also we can use. For example, you take this large. So between them there was a perforated salt bridge. So one half cell acts as OHC, oxidation half cell. Here it is acting as RHC. Same as this. Instead of taking two separate half cells within the same cell, one half is acting as oxidation half cell, another half is acting as reduction half cell. By using perforated salt bridge. No problem. Even it is also acting same as like normal electrochemical cell. Okay, so this is about the electrochemical cell and their construction.